Greetings everyone. Today we will discuss the equations of rotational motion.
Equations of rotational motion. We have three equations of rotational motion which are omega is equal to omega naught plus alpha t, where omega is the final rotational velocity, this is the initial rotational velocity, alpha be the angular acceleration. Second is theta is equal to omega naught t plus half of alpha t square, where theta be the angular displacement. Last one is omega square minus omega naught square is equal to 2 alpha theta, where omega and omega naught be the final and initial rotational velocities, alpha be the angular acceleration and theta be the angular displacement. Let's derive first rotational equation of motion, that is omega is equal to omega naught plus alpha t. For this, let us consider a rigid body rotating about the fixed axis with constant angular acceleration. So, we know angular acceleration is d omega by dt, change in angular velocity with respect to time. So, this expression can be written as d omega is equal to alpha dt. So, we have to find this expression in the form of total final velocity. So, we have to integrate this expression. For this, we require some limits. At t equal to 0, angular velocity is initial and at any time t, angular velocity is final. Say this is equation number 1. Integrate equation 1 within above limits. See d omega integration limits omega naught to omega, initial to final, that is equal to integration alpha dt, that is we have to use limits of time 0 to t. Now do the integration. This is the differentiation, this is integration. We get omega, limits outside the bracket, omega naught omega, that is equal to alpha is constant, integration of dt is t and limits outside the bracket 0 to t. Upper limit minus lower limit, that is equal to alpha, upper limit minus lower limit 0. So, omega minus omega naught is equal to alpha t, and this expression can be written as omega is equal to omega naught plus alpha t. So, this is your first equation of rotational motion. Now, see the second equation of rotational motion, that is theta is equal to omega naught t plus half of alpha t square. We know angular velocity is d theta by dt. So, d theta is equal to omega dt. Use first equation of rotational motion have omega is equal to omega naught plus alpha t. Let's say this equation is 2. From equation 2, we have, see, d theta is equal to omega naught plus alpha t dt. We have to find out the displacement here. So we have to remove this differentiation. For this whole expression is to be integrated within the certain limits. Let's say this equation is 3. At time t equal to 0, displacement is 0, and at time t, displacement is equal to theta. Now integrate equation third within above limits. See, d theta integration 0 to theta, that is equal to omega t plus alpha t dt, and time limits 0 to t. See, this factor can be written as 0 to t omega naught dt plus alpha is constant, integration 0 to t dt, and this factor as it is 0 to theta d theta. Now see, integration of d theta is theta, limits outside the bracket 0 to theta, that is equal to omega t constant, integration of dt is t, limits 0 to t plus alpha, integration of t is t square by 2, 0 to t. Now put the limits, upper limit minus lower limit, that is equal to omega t, upper limit minus lower limit, plus alpha by 2, upper limit minus lower limit. So theta is equal to omega t plus alpha t square by 2. So this is your second equation of rotational motion. See the third equation of rotational motion, that is omega square minus omega naught square is equal to 2 alpha theta. We know angular acceleration is d omega by dt. Now divide and multiply this factor by d theta. We get d omega by d theta multiplied by d theta by dt. And we know d theta by dt is angular velocity, that is omega d omega by d theta, because d theta by dt is angular velocity. So this expression can be written as omega d omega is equal to alpha d theta. Let's say this equation is A. Now let us consider certain limits. At time t is equals to 0, angular displacement is 0 and velocity is initial. At time t is equal to t, displacement is theta and velocity is final. So integrate this equation A within the certain limits. Now integrate equation A within above limits. See, omega d omega. Limits are omega naught to omega. That is equal to alpha constant d of theta. Limits are 0 to theta. See, what is the integration of omega? Omega square by 2. Limits omega naught omega. That is equal to alpha integration of d theta, theta 0 to theta. Put the limits, upper limit omega square minus lower limit. That is equal to alpha theta minus 0. Now see, omega square minus omega naught square is equal to 2 alpha theta. So this is your third equation of rotational motion.
That's all. Thank you.